Ever wondered how sorting algorithms work in programming, specifically the bubble sort? It's a straightforward sorting algorithm that repeatedly marches through the list, compares adjacent elements, and swaps them if they're in the wrong order. The beauty of bubble sort is in its simplicity. It's like organizing a bookshelf, comparing two books at a time and swapping their places if they're not in the right order. Now let's talk about how this works in our C programming realm. We start by defining a function called bubble sort that takes an array of integers and its size as parameters. Within this function, we have two nested loops. The outer loop walks through each element of the array, while the inner loop compares adjacent elements and swaps them if they're not in the right order. This dance continues until our array is sorted. Now why not take a closer look at the code to understand how bubble sort truly works? Dive into the code and you'll see the magic of bubble sort. The bubble sort function is defined as accepting two parameters, an array of integers and the size of that array. The array is the list of numbers we want to sort, and the size, well, that's self-explanatory. It's the number of elements in the array. Now we're getting to the heart of the algorithm, the two nested loops. The outer loop is our tour guide, leading us from the start of the array to the second to last element. Why only until the second to last element, you ask? Well, that's the beauty of bubble sort. With each full pass through the array, the largest unsorted element bubbles up to its rightful position at the end. So with each iteration of the outer loop, we can confidently say that the last I elements are already sorted. Therefore, we can reduce the size of our inner loop by I, the current iteration of our outer loop. Now let's look at the inner loop. This is where the real action happens. It's like a quality control inspector scrutinizing each pair of adjacent elements, one pair at a time. If the elements are in the wrong order, that is, if the element at position J is greater than the one at position J plus 1, it's time for a swap. The swapping process is a quick three-step dance. First, we store the value at position J in a temporary variable. Then, we replace the value at J with the value at J plus 1. Finally, we fill the now empty slot at J plus 1 with the value from our temporary variable. Voila! The elements have switched places. This process continues, with the inner loop making its way through the array and the outer loop shrinking the unsorted portion of the array until the entire array is sorted. After these steps, the array transforms into a sorted list. Next, see the algorithm in action. Time to see the bubble sort algorithm perform its magic. Imagine a list of numbers out of order. We're talking 64, 34, 25, 12, 22, 11, 90. Quite a jumbled mess, right? Now, let's introduce our bubble sort function. This function is like a meticulous organizer, stepping through the list and comparing each pair of adjacent numbers. If a pair is out of order, the function swaps them, making sure the larger number follows the smaller one. The function starts at the beginning of the array and works its way through, one pair at a time. It's a bit like watching a dance, each number swapping and sliding into place. With each pass through the list, the largest unsorted number bubbles up to its correct position, hence the name bubble sort. After the first pass, the number 90, our largest number, has bubbled up to the end of the list. On the second pass, the next largest number, 64, bubbles up to its rightful place just before 90. This process continues, with each pass pushing the next largest number into position until the entire list is sorted in ascending order. And voila, we started with a jumbled mess, but thanks to bubble sort, we now have a beautifully ordered list. 11, 12, 22, 25, 34, 64, 90. As you witnessed, the array is now sorted in ascending order thanks to the bubble sort algorithm. And voila, that's the bubble sort algorithm for you. We've unraveled how this simple yet effective algorithm can sort an array in ascending order. We dove deep into the heart of the code, understanding the role of the two nested loops and the crucial swapping process that rearranges elements into their rightful order. Remember, the largest element bubbles up to its correct position after each iteration. Thanks for joining in. Stay tuned for more intriguing insights into the world of programming.